I'm Daud, and in this session we are going to see how we can deal with the multi-class classification problems. Okay, so till now we have discussed binary classifier, which is a logistic regression that can deal with the binary classification problem. Okay, and binary classifiers usually distinguish between two classes, and multi-class classifiers that are actually also called multinomial classifiers deal with can deal with more than two classes. So, as we are studying logistic regression, so it is strictly a binary classifier. It is a linear classifier, which have equation like this. If I will show you here, p cap over 1 over 1 plus e raised to power minus mx, this type of equation. And if this probability will be greater than the threshold, then it will be a 1 class. Otherwise, it will be, if it is less than that, then it will be a zero class. So it is strictly a binary classifier. So if we want to implement multi-class classification or want to solve multi-class classification problem, then we cannot use directly logistic regressor. Okay, but there are also some algorithms like random forest classifier, Navier classifier. These can deal directly with the multiple classes because their structure, their equations are like this. They can capable of handling multiple classes, but in the case of logistic regression, this is not capable of handling multiple classes by its structure. So what we can do now? For that reason, we have two approaches to implement binary classification problem by using linear classifier. So we will discuss two approaches. In this session, we will discuss first approach, which will be a one versus rest approach, and there will be another approach. In that approach, there will be a scheme is combine multiple binary classifiers to obtain a single multi-class classifier. Okay, and there is another approach which will be make some changes in that approach. In that approach, we will make some changes in the structure of logistic regressor, like in the structure means in the equation of logistic regression, in the cost function of logistic regression, for the sake of obtaining multi-class classifier. Okay, this approach we will discuss in the next session. For now, we will discuss the approach of combining multiple binary classification. And one of the preferred approaches how we can combine multiple classes, multiple binary classifiers to obtain multi-class classifier. There are multiple schemes. We will discuss one versus rest scheme, which is this one versus rest scheme, and it is mostly preferred in the case of logistic regression. There is also linear classifier, which is a support vector machine. And if we want to implement a multi-class classifier, when we are using support vector machine, then we usually preferred one versus one scheme. Okay, but we will not discuss that. And it is also not much preferred. In the case of logistic regression, one versus rest scheme, which is this scheme is mostly preferred and it we usually use. So we will see what is OVR, what is the concept behind that. Okay, so first of all, let's say we have this problem statement in which we have four independent variables: sepal length, sepal width, petal length, petal width, and in the species column we have here three classes: Iris setosa, Iris versicolor, Iris virginica. The problem statement is here classify on the basis of sepal length, width, petal length, width to which species of iris the given sample belong. This is the problem statement here. As you can see, there are three classes involved, so we need a multi-class classifier here. Okay, so how one versus rest scheme is work from the word one versus rest. From this word, you can get an idea how it actually work. Okay, and it is also called sometimes one versus all scheme. Okay, which is OVA. People are using these OVR, OVA simultaneously for the same concept. Okay, what actually took it break down multi-class classification problem into multiple. binary classification problems, and then train a binary classifier for each binary classification problem. Let's say here there is a three classes, so it will break multi-class classification problem into three problems. One, this will be second problem, and this will be a third problem. Okay. Problem in here we will have a categorical column. In that case, we will have categorical column in which we have iris tosa as our target column, and here against each iris tosa we will have one iris tosa. We will have one here, and all other will be zero. Means this binary problem is either the given sample will be belong to stosa or not. Okay, we have break down this multi-class problem into binary problem. In the same way, according to second category, this will have ones and zeros. One, either the sample is belong to versicolor or not. In the same way, there will be another which will be a virginica. Okay, if a sample belong to virginica, then it is one, otherwise it will be zero. So you can see here three classification problem break down into three binary classification problems. So against each binary classification problem, there will be we will train a binary classifier. Okay, this will have the same structure, same idea, same cost function, same models equation, like we have discussed already. It's strictly a binary classifier. So it is able to classify that sample is belong to stosa or not. It will give a probability p cap that this percent chances that given sample belong to this stosa category or not. Okay, probability cap will be give the probability of belonging to stosa category. In the same way, for the second binary problem, there will be a second binary classifier which will give or which is able to classify that given sample is versicolor or not. It will be trained on this type of data set. Okay. Third will be um, for the virginica. So it is able to classify that given sample belong to virginica category or not, and it will be trained on this type of data set, on this type of binary data set, and this probability will be the belonging to the virginica category. Okay. So here you got an idea that these are three classifiers, and all of that will give three probabilities. Okay, this will be give probability belonging to stosa category, this will give the probability belonging to the versicolor category, and this will give probability belonging to virginica category. And here you got an idea, if there are three classes there will be three classifiers, binary classifiers. If there will be nine categories, let's say, there will be nine binary classifiers, and these binary classifier will be trained on nine binary data sets. Okay, so we will have we will after training we will have nine trained binary classifiers. Now how they can predict, okay, how the prediction phase will be here in case of OVR scheme. So whenever a sample will be passed, this sample will be passed to each binary classifier, and each binary classifier will give some probability, which classifier will give max probability out of all the probabilities. The class of that binary classifier will be considered as a output. Let's say here we are getting three probabilities against three classifiers, P1, P2, P3. Let's say P cap 2 is the maximum probability against all of these. So we will check which classifier giving this probability. This is given by the versicolor classifier. Okay, so the output is versicolor. In that way, this process is carried out. And you can see here there are three binary classifiers. So like each binary classifier we know have some equations like this. Classifier have some equation p cap y is equal 1 over 1 plus e raised minus, as there are four independent variables, so there will be four coefficients here will be, and one for the intercept, so here will be m0 plus m1 x1, x1 is here sepal length, plus m2 x2, x2 is sepal width, plus m3 x3 plus m4 x4. Okay, this type of equation each model will have. It means each model have five parameters here in that case. So there are total 15 parameters, five parameters in each binary classification in each case for each binary classifier, and during the training phase for each binary classifier is to obtain optimal five parameters, okay, for each case. So here you can see when you will use Scikit-Learn, we will see how it actually we can see the coefficients or intercept for that case. Now here the important a little bit, okay, little bit important. It's not really. It's just related to Scikit-Learn. In the case of Scikit-Learn, actually the probabilities these that we are getting from each classifier are when we'll sum these probabilities, it will be not equal to one. Okay, the reason is that all of the probabilities are providing by these individual binary classifiers. So to make sure that the sum of these classifiers will be equal to one, this Scikit-Learn what will do again generate three probabilities. In that way, it will sum the probabilities that we are getting from each classifier, and then probability 1 divided by the sum, it will be a probability belonging to one class. Then the probability of belonging to two class, and then the probability of three class. So Askelan function, that is you are already familiar with this predict underscore prob. This function will give the probabilities in that scheme. Okay, and you get an idea how this scheme is actually. So without wasting time, we will go towards the code part. Code part is pretty simple. And before that, I will show you this documentation, which is logistic regression. And you already know about this multi-class class. Here, there are two values, OVR and multinomial. In the OVR scheme that we are discussing right now, and multinomial scheme will be tomorrow's session. So if the option chosen is OVR, this is actually the Escalon. So by default option is auto, and which is introduced in the later more latest version of that Escalon. Before the default was OVR. So if the option chosen is OVR 1 versus est, then a binary problem is fit for each label that we are discussing, that if there are four classes in binary problem and we have selected uh, multi-class is equal to OVR, then for each label, if there are four classes, then there will be four binary classifier will be trained in that case. So for multinomial, we will discuss it later. For multinomial laws, minimizes multinomial laws fit across the entire probability distribution when the data is binary. We will discuss that in the later session. So multinomial is unavailable when the solver is linear. Okay, to solve the optimization problem during the finding best parameter values during the training process, there are different solvers. So if you have chosen the solver is equal to linear, then you can not use multi-class is equal to multinomial. And auto selects automatically OVR. If your data is binary, it detect by itself. If data is binary, it select OVR. Otherwise, or if the solver is linear, otherwise it will select multinomial scheme. Okay, now we will implement that by the code. Here I am importing extension NB Black, and this is pretty good extension for the sake of structuring your Python code. Here I am importing some important libraries. Then here I am importing my iris dataset. You can see there are four columns here, independent, and fifth one is which is target column, and this is actually the categorical column. And there are no null value here. 150 samples total we have here. Okay, this is just a commented part. It's for the sake of taking screenshot for the theoretical explanation. So X Independent variables, y is dependent variable. Here you have seen that I have not converted my categorical column into numerical column, because if you will pass directly to sklearn, it can do it by itself. So no need to convert that before. But mostly in the case of binary problem, mostly prefer that you should do this conversion before passing the value, because you have to specify that majority class as a 0 and minority class as a 1. So here train test split according to the 30% scheme. Test size should be 30%, which will be 45 samples we have taken for the sake of testing the model, and 105 samples for the training. Here, just not to evaluate the model, not to obtain the optimal model, just phase this session is to understand the concept of multi-class classification by using a linear classifier, which is we are discussing here logistic regression. So here binary classification, we have passed their value OVR, one versus rest scheme, and we have passed their X train Y train. So what it will do, we have passed our independent variables and dependent variable. It will divide this, it will detect first how many categories in Y train. If there are three categories, it will convert this data set, which is multi-classification problem, into three binary classification problem. Then, according to each binary classification problem, it will train a binary classifier. Okay, so as there are three binary classifier, so there are first you can see here there will be three classes. If you will use the attribute of how it has detected, it has detected that iris tosa, iris versicolor, iris virginica in that white train. Okay, and it has arranged in that way. At the zeroth position, it is iris tosa, one position versicolor, second position will be virginica. It means the first classifier is binary stosa, second is versicolor classifier, and third classifier is a virginica classifier. In the same way, your coefficients are available. These are the coefficients for the stosa, these for the versicolor, and these for the virginica. In the same way, our intercepts are available for the stosa. This is for the versicolor, and this is for the virginica. Okay, we are done with the part of training. Now we will see how testing part is carried out. Okay, so let's say we have this sample and we want to test that we want to test our model, that what it will give the prediction against this sample when the sample length is 6.6, sample width is 3.0, 4.4 length, and pattern width is 1.4. What will be the prediction by this OVR logistic regression, okay, that we have trained here. So here this is just a sigmoid function. I have here I have got that, which is returning 1 over 1 plus e raised to power minus x. So I will use it later. Here I just for the explanation, if I will show you here that the model that we have trained here, binary classifier, this is the model that we have trained. If we use binary classifier dot decision function and pass these four values, it will give three scores against each classifier. Okay, these scores. And these scores, in the case of, let's say, we have three classifiers, Stosa classifier, and the second classifier is versicolor, and third is virginica. And each have the model's equation like this: 1 over 1 plus e raised minus and 1 m 1 x1 plus so on to m4 x4, and there is a 1 which is intercept here. Okay, so this is actually the score. We usually consider this as a score, and the sigmoid function of that score usually consider as a probability. Okay, so this decision function is actually give us that scores that I have discussed here. Okay, just the values of given sample multiplied with the coefficient of the uh, models that it has obtained during its training process. So we will see here this sample we are passing here, and these are the coefficients and intercept. So we will manually will do that. We will multiply these These are the coefficient of Stosa. We will multiply our samples value with these coefficients, then we will add an intercept to that, and this will give us the same score as the decision function of Scikit-Learn is giving us. So here I have just data frame in which all the values of one classifier along these are the, here you can see these are the values of Stosa classifier, coefficient values of Stosa classifier. These are the for the particular, and these are the Virginica. When I have multiplied, this will be samples value. I have obtained these here. When I will obtain add intercept values, I have here three scores, and these are the same three scores that I am obtaining from the sklearn, okay, at decision function. So you can get an idea how this decision function is working here. It just for the sake of explanation, you can use decision function for if you want to see these scores. Okay. So when you will apply the sigmoid function on that scores, okay, you can also estimate which the output of that against that sample from our classifier, against that sample that we are using here. We can also predict the output from the scores. Okay, here you can see there are three scores here. There are three scores, and which score is highest? The middle one score is highest, and middle score is obtained from the versicolor binary classifier. So the output against will be predicted as a versicolor against this sample. Okay, we can also predict it by the decision score, and just for the sake of some to convert these values in the form of probabilities, we take a sigmoid function, okay, of these scores, and sigmoid function here you can see these are the sigmoid function is giving us the values, and here you can see that when we will sum these values, these are not equal to 1, but when you will use the predict probability function provided by sklearn, you will have these values. Okay, this is saying that 2% chances that of that given sample is belonging to the Stosa category, 67% belonging to the versicolor, and 31% chance that this sample is belonging to the Virginica category. Okay, how it is obtained, and you can see the sum of these three percentage is equal to 1, but that we have manually calculated, these are not equal to 1. So to make sure that these values, sum of these value will be equal to 1, we will divide, we will first sum these values, which will be 0.747, and then we will divide each probability by 0.47 to obtain these three probabilities. Now again we will have three probabilities, and their sum is equal to 1, and it's the same concept that I have explained you here, that sklearn is given you in that way. Okay, this green box is explaining here this this. Okay, these three probabilities we obtain from the sklearn. Okay, so when you will use predict function by the this binary classifier that is trained on the scheme of OVR, you can see our output is versicolor, and our true value against this sample is also versicolor. Okay, you got an idea how we can implementation is quite easy. Just pass the value of VR again, again the parameter of multi-class. Okay, and you can you are able to implement OVR, and you also got an idea of multi-class classification, how you can obtain multi-class classification classifier by using the OVR scheme. Okay, by combining multiple binary classifiers in the scheme of one versus rest. Okay, here one important concept that I want to discuss here is this, that there is no concept of threshold setting here. Okay, in the case of multi-class classification problem, there is no concept of threshold setting, and you can easily get an idea why there is no threshold setting. You cannot set some particular threshold and cannot manipulate the confusion matrix by directly, because you have seen the structure of solving that problem is a little bit different from the structure that we were having in the case of binary classification. Okay, that we are having in the case of binary classification, the structure is different. Here you can you have just two classes, you have just one probability, and you can manipulate your confusion matrix, you can manipulate your outputs. But in the case of multi-class classification, you cannot manipulate. Even this is one versus zest scheme, which is combining multiple classes or multiple binding classifiers. Even in the case of the classifier, which is by nature, it is multi-class classifier. By nature, it is, we are not combining here multiple binding classifiers. By nature, this approach will have multi-class classifier, and again, there is no concept of threshold setting will be here. Okay, so we cannot manipulate these confusion matrices. And in the evaluation of multi-class or performance measures of multi-class classifier, we will discuss this in the detail. But for now, you get an idea what is obvious scheme. In the case of linear classifiers, that like we are using here logistic regression, we can not directly use this as a solve binary problem. Although in the library it is uh, pretty easy, and library detect by itself either this problem is belonging to it's a binary problem or multi-class problem, and pass the value accordingly. But for the concept, you cannot directly use linear classifier to solve the binary problem. Okay, so you have seen the obvious scheme. In the next session, we will see another scheme. For now, thank you.